I have long held the belief that wireless charging of electric cars doesn't make any sense. And the reason why it doesn't make any sense is because it's inefficient. And because it's inefficient, it means it takes a really long time, it requires a ton of power, and it costs a lot more. And so why would you want wireless charging? So when I heard that this vehicle, the Porsche Cayenne Electric, offers wireless charging, I thought, who cares? And then I read that the wireless charging for this Cayenne Electric can be as efficient as 90%. But okay, if that's just the peak number, real world, I'm sure it's way lower. And so again, I don't need to be excited about wireless charging on this car, right? It's probably not actually achieving 90% most of the time. Well, I asked a bunch of questions to Porsche's engineers and they answered all of them. And it turns out I was wrong about pretty much everything. Wireless charging is incredible. So let's talk through it. All right, first let's back up and get to why I thought wireless charging was a bad idea. So the way wireless charging works is you have a pad that's mounted on the ground, and that pad has a bunch of wire coils in it. So wireless charging is in fact using quite a bit of wires, probably more than wired charging. But regardless, there's no physical connection between the car and the charger. So this wireless pad has this wire coil in it, which if you put a current through that wire coil, well, that creates a magnetic field. Well, if you put an alternating current through that wire coil, then it creates an alternating magnetic field. So if you then bring an antenna and you place it over that alternating magnetic field, well, it induces an alternating current within that wire coil that you've placed over it. So then you can use that alternating current to charge the battery in your vehicle. Well, the problem is that this process is not very efficient. So you have these losses, especially if you increase the gap at which that distance from the wireless charging pad to the receiving antenna is. If you increase that gap, you increase the losses. It's not as efficient. So I found a test that looked at wired versus wireless charging of an iPhone. And they found that the charging efficiency when it was a wired connection was about 70%. And then they tried 3 different wireless chargers on the iPhone, and they found that the efficiency ranged from about 35% to about 55%. Fun fact, the worst charger was actually a Tesla wireless charger. Anyways, the worst one was at 35% efficiency, about 35%. So think of that, 35% versus 70, that's half the efficiency. It means you need twice as much power or twice as much time, and it's gonna cost you twice as much, right? So it's just silly. At an iPhone level, you know, who really cares? It's not that much energy, it's not that much time, it's not gonna be that big of a deal. But at a car level, it's a ton of energy, and so it is gonna be a big deal. So why would you possibly use wireless charging when you know you're gonna have all those losses? Especially when you consider people are already concerned about the power draw of electric vehicles, and now we're saying, okay, with these wireless chargers, you're gonna have to even ramp up that power draw even greater to get them at regular charging speeds. So because of seeing tests like this, I thought, yeah, wireless charging doesn't make any sense. But now let's put it in context of a vehicle like this. So we start with our power from the grid, right? So we're pulling from our circuit breaker or our outlet, and we've got 48 amps at about 240 volts. And so with that, we're putting that power and we're going to convert it from alternating current, which is what we're getting from the wall, and we're going to convert it to a direct current, DC, AC to DC. Wow, look at this cool tunnel. Wow, this is incredible. Way to be, Spain. Then with that DC current, we're going to convert it to high frequency AC current. So 85 kilohertz AC current within that antenna. So you've got this really high frequency alternating current within your floor pad. That, of course, is creating that alternating magnetic field, which is inducing an alternating current in the antenna, which is on the vehicle. So then we're taking the AC current on the vehicle and we're converting that to DC. And then with that DC, we're finally charging our battery pack. So as you can see, that's quite a few steps. And if you were to just convert the AC from the wall to DC and then charge your battery, hey, that's way fewer steps, so that's going to be more efficient. All right, so how much difference in efficiency is there actually between wired and wireless charging with, for example, this car? And so I already mentioned, yeah, Porsche said it can achieve 90% charging efficiency with the wireless charger. Now I asked them, what is the actual range that you're going to see in real world conditions on the high end and on the low end as far as charging efficiency? They said on the high end, if you have this car perfectly positioned and it'll lower power down a little bit so it gets closer to that charging pad, you can achieve 92% charging efficiency. On the low end, they said if it isn't perfectly positioned, it still achieves 89% charging efficiency. What? Now, perhaps you don't believe me, and that's fine, but Porsche says the charging standard that this wireless charger falls under requires that it has a minimum charging efficiency of 85%. And again, they're able to beat that. They're at 89% minimum. Now, this does mean there is a specific position you want the car in order to achieve that efficiency. So Porsche enables you to have left to right plus or minus 100 millimeters or about 4 inches that you can position the car, and forward and backward plus or minus about 75 millimeters or about 3 inches from that center point where you're going to have that ideal charging efficiency. But as long as you fall within that range, you get that 89% and it enables the charging for the car. Porsche also said, which I thought was interesting, that the state of charge of the battery and the ambient temperatures don't actually play in very much as far as charging efficiency. It's really all about positioning. All right, so as a bit of a thought experiment, let's compare level 1 wired charging versus level 2 wired charging versus level 2 wireless charging. And so if you look at the power, actually the mobile connector for Porsche in the US is at about 9.6 kilowatts versus the 11 kilowatts with the wireless charger. So the wireless charger is actually the faster option in the US. And of course, if you look at a level 1, you're only charging at about 1.44 kilowatts. So very slow rate. It would take about 125 hours to charge this car fully with level 1. The crazy thing about level 1 though is it's very inefficient. These are numbers directly from Porsche. Level 1 wired, 60% charging efficiency. Level 2 wired, 96% charging efficiency, and then we're just going to go with worst case for level 2 and say 89% charging efficiency, though realistically that number can be as high as 92%. All right, so as you can see here, level 2 wireless in the US at least is actually charging faster even once you take into consideration efficiency than level 2 wired. So about a kilowatt faster, and as far as charge time, about an hour quicker. Now, one of the interesting things to think about is how much total energy do you need in order to charge this battery from 0 to 100% for the 108 kilowatt hours of usable energy that the battery has. Total battery pack size, 113 kilowatt hours, 108 usable. So with level 1, because it's so inefficient, it's going to require 180 kilowatt hours of energy in order to deliver the 108 kilowatt hours into the battery pack. For level 2 wired, that number is its lowest, 112.5 kilowatt hours. And then for level 2 wireless, 121 kilowatt hours. So yeah, a little bit more. But then take into consideration how much does this cost. So I looked at average electricity prices in the United States. That turned out to be about 17.3 cents per kilowatt hour. So as you can see, the level 1 wired option, $31 for a full charge versus $19.46 for a full charge on level 2 wired. So a big difference there in cost. But for level 2 wireless, only $21. And again, this is assuming the lowest charging efficiency on that level 2 wireless. So only a $1.50 difference. And again, you know, we're talking about a 6-figure Porsche. So a $1.50 difference in charging, who cares? But just for fun, let's look at a lifetime worth of energy and see what the cost breakdown ends up being. And so we're going to assume that we're going to travel 200,000 miles for the life of this vehicle, and that on a single charge, it gets 300 miles of range. Now, Motor Trend has tested the vehicle. They actually got 350 miles on a single charge, but we're just going to be a bit conservative, say 300-mile range for the battery. Now, traveling 200,000 miles, your cheapest option, of course, is going to be that level 2 wired connection, the most efficient, and that's at about $12,973 for the total cost of charging this thing over its entire lifetime. Compare that to level 1 wired, $20,760, almost $8,000 more, versus the level 2 wireless, only $14,000. So again, it's only about $1,000 more over the entire lifetime of the vehicle to use wireless charging versus wired. And so if it is more convenient for you, who cares? The cost difference is basically negligible. Now, of course, electricity is going to vary in price from region to region, but again, considering how expensive of a vehicle this is, when you're looking at these small differences in price for total life charging, it's really not a big deal. Now that said, you do have to pay for the hardware, right? That's the expensive bit. So Porsche says the ground pad for the wireless charger, $6,500 about, and then for the vehicle pad that's installed on the Cayenne Electric, $1,650. So it is not a cheap option, but again, this is a Porsche. And actually, if you look at the combined cost of the charging pad and installing it on the vehicle versus level 1 wired charging, the cost difference isn't all that much just because level 1 wired charging is so inefficient. So level 2 wireless, basically a better idea than level 1 wired, and it comes real close to level 2 wired in terms of the actual cost of the energy. This portion of the video is sponsored by NOCO, who sent me their NOCO AL5 portable air inflator. The NOCO AL5 is their most compact battery-powered air inflator, meaning you can easily fit it in your glove box or trunk. I love leaving an inflator in my cars in case I need to top up, or say I need to plug a tire from a screw or nail while on the road, I can re-inflate the tire after. And if your vehicle includes a spare, it's easy to forget to keep it properly inflated. So this ensures you're ready to go if you need to use it. The NOCO AL5 can supply a max pressure of 130 psi, can fully inflate a tire from 0 to 40 psi in just 7 minutes, and has an integrated sensor so you can simply select your needed pressure and it automatically stops at your target. It's also perfect for bike tires, and it includes a flashlight as well as a USB-C charger in case you need emergency power. For peace of mind, I'm keeping the NOCO AL5 in my rear seat storage, so I'm road trip ready. You can grab yours with the link in the video description. So how impressive is this? I mean, Porsche says most of the time you're going to be getting 90% charging efficiency with this wireless charger. So you're getting basically equivalent efficiency as a wired charger, and you don't have to plug anything in. You simply drive over the charging pad, it communicates with the vehicle, and then it starts charging it. Now, you might wonder, why is level 1 charging with a wired connection so inefficient? And there's a couple good reasons for this. First of all, you have to think about fixed overhead. So once you plug in that charger, you've got onboard computers that are going to be running on the vehicle, right? You've got your charger, you've got your AC to DC converters. All of these things are going to have some fixed overhead to be operating. Perhaps you have telematics, so you're communicating the charging rate with cell phone towers. So all of this takes energy. So there's going to be an overhead. Say that overhead is 300 watts. Well, that 300 watts is 20% of your charging rate right there without even putting anything into the battery. So then you have to consider about the efficiency of the charging itself. So then with the charging, let's say you have your AC to DC converter, well, those are sized appropriately, right? So if it's expecting you to regularly be charging at 11 kilowatts with a level 2 charger, and you're only charging it at about 1 kilowatt on a level 1 charger, well, then you're operating that converter at a very low load. And so it's designed to be most efficient at the load it thinks it's going to be seeing more often, right? These higher loads. And so as a result of that, it's charging at a much lower efficiency when you're in that level 1 zone, and you have all of the overhead. So ultimately it ends up being something like 60% charging efficiency. Terrible. And another interesting point is that 92% charging efficiency is not the limit for wireless charging. In fact, I found a study done out of Oak Ridge National Laboratory using a Porsche Taycan, and they were able to wirelessly charge it, yes, you're hearing me correct, wirelessly charge it at 270 kilowatts, so fast charging, at an efficiency of 95%. And that was over a 50% state of charge increase. So it was genuinely charging it at 95% efficiency wirelessly. So this technology is able to get actually really close to what you can get with wired charging. So to summarize, what do I know about wireless charging? Well, it turns out I know a lot more about it today than I did yesterday. Now, perhaps you're still not convinced about wireless charging because there's a lot of other scenarios we haven't talked about yet, but I asked Porsche a bunch more questions. So let's talk through some of them. What if, for an example, a cat runs under the car while it is wirelessly charging? Well, the wireless charging pad actually has radar on it to sense living objects, living animals, living whatever coming near it, and it automatically shuts it off. So if anything living comes near the charging pad, it will automatically turn off. Well, what about metal objects? Say you drop your spanner, your wrench onto the charging pad. I mean, this is not all that different from an inductive stovetop, right? So you put a piece of metal on there, you could put a lot of current through it, right? Well, actually, through a resistance coil system, they can detect if any metal objects are on that charging pad, again, turn it off. They also, as a backup, have temperature sensors on the charging pad, so they can detect if it starts getting too hot, they know something's wrong, it turns off. Well, what about getting snow or dirt or water or ice on the charging pad? Actually, the whole charging pad is designed to be either used in your garage or outside. It's totally fine to use it outside, and you can hard mount it, or it has little rubber feet so that it stays in position. So as far as dirt, ice, snow, anything piling up on top of it, Porsche says it's no big deal, and actually they say it won't even cause a meaningful difference in charging efficiency. Now, is this device fragile? Like, can you drive over it? Yes, you can drive over it. Simple as that. You could park your tire on top of it if you want to. You're not going to be charging your car, obviously, but you're not going to damage it aside from perhaps some scratches if you just drive over it. How much does it weigh? So the floor unit weighs about 50 kilograms or about 110 pounds, while the receiver antenna that is mounted on the vehicle weighs about 15 kilograms or about 33 pounds. Now, what about other safety issues, like if someone has a pacemaker? Well, again, Porsche took this into consideration, right? If it detects anything living nearby, it automatically shuts off. So if you have a pacemaker, no problem. Now, crazy people will still say crazy things about this kind of technology, right? The same reason why they don't like, inductive stovetops or airplanes or cell phones or 5G. Crazy people gonna be crazy, but there's no reason to be afraid of this tech. Now, could you use this wireless charger with another electric vehicle? Say you have two electric cars. Well, of course it would need the hardware, right? The other vehicle would need the antenna, but there's nothing proprietary that is preventing it from happening. Porsche designed this whole system under a common ISO communication standard, so there's nothing patented or blocking you off from using it. Yes, you do pair the vehicle with the charger, so there's communication between them, so your neighbor that also has a Cayenne Electric can't just drive over and steal your electricity. But once you've paired a vehicle with it using this common ISO standard, right, then you can charge it. So it doesn't necessarily limit it to Porsche vehicles exclusively if other manufacturers happen to have wireless charging on their cars in the future that have this same communication standard. So I think that's probably the most realistic negative of the whole thing, is that, if your car doesn't have a receiver antenna, you can't charge it. So you'd have this device that would only work with one of your electric cars. So you have multiple, then you can't just plug it in with the same plug that you plug into every other car. But it's the convenience that's the real benefit, right? You drive into your garage, you drive on top of this thing, it automatically starts charging. You never have to think about it. I mean, in theory, if you only charge at home, you might not ever actually open the charging door on this vehicle. I mean, you might never do it. That's kind of wild to think about. It has plenty of range, so as long as you're not taking a really long road trip, yeah, it's feasible. But are there any other benefits to wireless charging? And I think one of the big ones is when you think kind of far ahead into the future about autonomous driving. So if you have a vehicle that it pulls you up, autonomously drives you to a restaurant, drops you off at the front, and then it leaves, and it goes and finds a wireless charger, then it just drives over top of it and it starts charging. You don't have to worry about having something plug in a physical connection to the vehicle so that you can start charging it. It can just do it automatically by driving over a pad. And so then the whole kind of scenario just becomes more seamless, where it just drives off, it parks in a parking spot with wireless charging, it charges up. When you're done with dinner, it comes and picks you up and it's charged. How cool is that? And as we've seen demonstrated with Oak Ridge National Laboratory, you can actually have really fast charging speeds with wireless chargers. Now, speaking of charging speed, perhaps the most impressive thing about this Cayenne Electric is the battery architecture, because it can charge at ridiculous speeds on 800-volt charging systems up to 400 kilowatts. This is absurd. In America, most of the ones that we have top out at 350 kilowatts. And if you visit a Tesla supercharger, which is at 400 volts, volts, then this can still charge at 200 kilowatts. And you might say, okay, 400 kilowatts peak charging, who cares? What's the curve actually look like? The curve is ridiculous. You can charge above 350 kilowatts from up till about 50% battery state of charge, and above 300 up till about 70% state of charge. So realistically, the charging curve is insane. You can put a ton of power into this battery pack very quickly and get back off on your road trip. Realistically, you could be taking 10-minute or less pit stops with this thing on a road trip. Oh, and it can regen up to 600 kilowatts. What? So part of this is the battery, it's got their unique chemistry, their unique cells, and they also have cooling on both the top and the bottom of this battery pack. So they don't even do that on the Taycan. So really good cooling for this battery pack, and it's able to put out a lot of power, and it's able to accept a lot of power. Speaking of putting out a lot of power, the Cayenne Turbo Electric, over 1,100 horsepower, 0 to 60 in 2.4 seconds, the quarter mile in under 10 seconds. So we've got SUVs that are doing quarter miles in the 9s. This is insane. What a beautiful spot to try out some launch control. Put on both pedals, off the brake, oh my God. And you hit 150 kilometers per hour. I mean, the speed limit, which is 90 kilometers per hour, very quickly. 0 to 60 in around 2.4 seconds. Probably can do it slightly quicker than that. This is genuinely one of the quickest accelerating vehicles I've ever driven, and it's an SUV. It's a large SUV. Driving this thing through corners at these speeds in an SUV, wow, it handles well. I will say, they have the sounds artificially piping in. You can, of course, turn that off. And it sounds fine in the Sport mode. In Sport Plus, I think when you really get on it, it sounds pretty artificial. But if you're at partial throttle in Sport Plus, it sounds fine, honestly. It's very believable. As far as what this vehicle has been like to drive, it's been exceptional. The ride quality is so good. I've had it in comfort mode basically the entire time. An incredible suspension on this thing, super quiet on the interior. Love the driving experience. And actually, one of my biggest complaints on Taycan is that I don't really like the way the brake pedal feels. But here, I don't mind it at all. I like the brake pedal. You don't have that dead space that I find was the case on the Taycans that I drove. My one complaint is the same for all Porsche electric vehicles. They don't offer one pedal driving. So you can't come to a complete stop and leave your feet off both pedals. No one pedal driving in Porsche electric vehicles. That's their philosophy. They're sticking to it. I wish they offered it as an option, but they do not. But wireless charging, that's the new option for this vehicle, and it turns out it's actually pretty logical, pretty cool. Thank you all so much for watching. If you have any questions or comments, feel free to leave them below.